This is a video that corresponds with Introduction to XML, your PowerPoint presentation that's linked off the course site. This presentation is basically to get everyone introduced to XML, why you're taking XML, why is it important, what is it, and a little bit of history and background about the technology of XML. Some of you may be coming here to the class with a background in, say, HTML or web design, perhaps programming even. Maybe you've taken a, say, a Python class or a PHP programming or C++, those sorts of general purpose programming languages. Or perhaps you've worked with databases like Access, or even Excel. We talk about Excel. It's not really a programming language, but it's a sort of spreadsheet database type technology, all of which are very helpful when in this class, but not required. This class assumes no technology background. But HTML is the big one, and what we found with HTML is that it was really good at displaying information, but very poor at organizing it. And hence that's why XML was created, basically to help store and manage information and data. So over the past 15 years, XML has become a very powerful tool, almost a requirement that if you work in web technologies, you're at one point or another going to interact or use XML on some level or another. And together with its related technologies, XML is essential for doing any kind of data representation on the web or even off the web, but the internet is where it's used mostly. And so in a nutshell, XML is designed to describe data, whereas HTML was designed to display data. HTML is all about looks. That's how you can think about HTML. And XML, maybe it's more sort of the brains of the markup languages. XML is an acronym. We'll get to see a lot of acronyms in this class, and XML is kind of a funny one because the first word in the acronym actually gets its initial from the second letter in the word, so it's extensible, but it's X, markup language, XML. XML is a tag-based language, so it's very much like HTML. You see the ML in HTML. It's a markup language similar to that. It uses tags, but the big difference is that XML, we can make up our own tags. Hence, it's extensible. It's extensible, and extensibility is probably its biggest benefit, or one of the major benefits of XML. HTML, on the other hand, is a set. The tags are set, so you can't just decide you're going to add new tags to HTML. It's a foundation of Web 2.0 applications. Web 2.0 is already sort of an aging kind of paradigm, but it really is what took the web to the next level, and it still continues to facilitate a lot of innovation in web technology. So here we have RSS, AJAX, and XHTML, and many others that we'll get to learn in this class. It's designed to describe data, not display it. Tags are not predefined as HTML, as I mentioned before, and really important point to make is it's a W3C standard, and we'll talk about W3C standard and the W3 C consortia quite a bit in this class. XML doesn't really do anything, so it's not programming per se. I often refer to it as a technology. Sometimes I'll call it code, markup, maybe programming, but it's really not programming in the sense that, say, like Python or C++ or Java. It's really a different kind of language. But we do, having said that, we will do some kinds of programming, but it won't be with plain old XML. It'll be with XSLT or XPath, those sort of languages, or markup languages rather. Again, HTML is all about looks, whereas XML is sort of the brains, if you will, of the markup world. A little bit of history about XML. XML was developed in 1998, so the technology we're going to work with is actually relatively recent, but it came out of a technology called SGML, or Standard Generalized Markup Language. Doesn't really roll off your tongue very easily, but there it is. SGML is a language that dates back to the 1960s, so you have to bear that in mind. As we progress through the course, you'll see some sort of leftover things from the SGML world, and some aging aspects of XML, but we'll talk about that in a little bit. SGML was almost single-handedly developed by one person. It was 3 people, but really Charles Goldfarb is the person who pictured here who gets the credit. He was not a technologist, not a programmer, not really a science guy. He was actually an attorney or a Harvard law professor of some sort, who actually coined the term markup language, and basically he developed it so that his colleagues could share documents and marked up information over what was called the internet then, not the World Wide Web, but the internet. So SGML was used to basically encode documents so that people could share them over the internet. Later on, XML, what we're going to use in this class, basically was an outgrowth of SGML, and it was developed by 11 members, over 150 consultants, and 3 years to develop. In 1998, the W3C released the first version of XML, XML 1.0, and the last version was 1.1 in 2006. There's been some talk about a new version of XML that would be, I guess, XML 2.0, but no serious plans yet. The big difference between SGML and XML is that, or one of the major differences, is that SGML was really developed by a very small community and used more or less in a very small community of users, whereas XML, the World Wide Web was already in existence, and so a lot of people were using the web, and therefore a lot of people had a vested interest in how this new markup language is going to be developed, and hence you can see why there are so many different players, if you will, involved in its creation. And W3C in some way helps facilitate all these different professions and stakeholders in the development of XML. And we'll talk a lot about various professions and how XML has really become a technology that almost every single discipline has some markup language that they use that's in XML, and we'll talk about that later. But before XML, there was HTML. Perhaps some of you have laughed or heard the joke that that Al Gore invented the internet, and it is kind of funny because it's a little bit of a misnomer or misunderstanding, but he did basically create the legislation so the World Wide Web could come into existence, and this bill or act was known as the High Performance Computing and Communication Act of 1991, also known as the Gore Bill. So there he is, pictured Al Gore, very young Al Gore. HTML, or hypertext markup language, the markup language that really allowed the World Wide Web to be realized as you and I know it. The infrastructure was built, but there was really no sort of means to communicate over it. So Tim Berners-Lee invented not only the World Wide Web, but brought HTML into existence as well. Not widely used, though, until HTML 2.0 was released in 1995. Then we had 4.0, which is what I learned when I learned HTML. That's what I was using in 1998. And we were stuck with that for over 10 years, which was hard to believe. But when HTML 5.0 came out, and it really still is, in my opinion, brand new, even though it's already 3 or 4 years old, HTML, the jump from 4.0 to 5.0 was a huge jump. And toward the end of the class, when we start to deal with SVG, scalable vector graphics, we'll get to see some of the power that HTML 5.0 has brought to the web. HTML HTML is a simplified version of SGML so that non-experts could mark up documents. So again, as I mentioned, SGML is a very small community of users. A lot of them perhaps not technologists, but were highly initiated, so it wasn't someone just off the street that could start using SGML. You really need to know what you're doing. HTML, on the other hand, was very simplified. You can pretty much learn HTML in about an hour and design a very simplified website, simple website, but you can do HTML nonetheless. One of the problems with HTML was the good thing is it made the internet revolution possible. It was so easy to use, but it was almost too easy. And so we, in a very short period of time, created an entire internet filled with HTML documents with very little structure, very little semantic meaning given to them, and we'll talk about that in a few slides. Here's pretty much a landscape, if you will, of markup languages. We have SGML in the big circle there, and then to the right, XML, sort of the baby of SGML. SGML, before XML was developed, we obviously had HTML we just discussed, but there was also something called DocBook, which is still in existence. DocBook we'll talk about in the next slide, but it's kind of a sort of a proto XML / HTML technology. But for this slide, let's talk about XML as pretty much the baby of SGML, and then from XML we have HTML, MathML, ML, and SVG, and many other technologies that's been sort of come about because of XML. We'll talk about some of those. DocBook, I'm not going to spend too much time on that. On DocBook, basically it was a schema that was developed in 1991. It was used, as the name suggests, to write books, especially technical information. Created and used before the advent of XML, created and maintained in part by O'Reilly Books. O'Reilly is actually it's the textbook for this course. I think their visual quick start, the Peach Pit Press, I think they're a imprint of O'Reilly now. I'm not sure, I'll have to double check that, but O'Reilly is a big player in all the programming, computer-based publishing, and so they still use it. Evidently, you can go out on the web and find the markup library for DocBook. It uses SGML and XML. There's a lot of crosswalks between that. Has some compatibility issues, but the main takeaway with this is DocBook was sort of a bridge between SGML and XML. But it's on the decline. The only people who are probably using it are people who can't afford, or for whatever reason have no reason to get out of DocBook and just go to XML. But it's unlikely that you'll run into it out in the field. A little comparison table here between HTML and XML. HTML is optimized for World Wide Web, very easy, allows for a lot of non-standard markup. Sloppy syntax might be a way to look at it. Content and format not separated, which is very key. Fixed set of tags, so it's not extensible. XML, on the other hand, separates content from format. It enforces clean markup, so we'll talk about what legal XML is. That's clean markup. It's meaningful. The tags have meaning that you use, or they should have meaning, and it's self-describing syntax. And we'll get into that in later in the presentation. And the tags can be user-created, since XML is extensible. HTML lacks meaning in general. What does this HTML tag mean? So we have what we would consider an opening tag here. We have something just TD, and then we have some information in here, and then we have a closing tag. Well, the TD is kind of tough because we know from the HTML world, TD is usually a table data cell. It's a tag for making a table in HTML. But the markup really does not tell us what the information is about. In this case, if we were doing HTML, we would just say, oh, that's a table data cell. But if this was an XML, if we were to do an XML tag, we would do it differently. But with this case, we really don't know what this 12208 means. It could be the weight of an automobile, 12,000 pounds. Could be perhaps the number of students enrolled here at this university, or it could be a zip code for an Albany address. Well, we can kind of infer, because it looks like a zip code, that it probably is, but there's no way that a computer would know that, and definitely a human would not know that if reading it if this was a large XML document. So again, appearance is the primary goal for HTML, and it cannot separate content from presentation. So HTML, there's no way that I can make a tag that describes in HTML what this data is here. So let's move on. XHTML to a certain degree helped fix some of the problems found with HTML. It was more restrictive, so documents must be well formed. That's a term we'll use a lot in this class. Elements must be properly nested, so it doesn't allow for any of that sloppy syntax or nesting HTML tags sort of out of order. No open elements were allowed, so for example, you can't just use a P tag and not close it, or have a self-closing tag. Some of you have done HTML, you probably know what I'm talking about there, but we will discuss this more in depth. It uses a standard XML parser, so it was a little stricter, which is a good thing. You want a strict interpretation of your markup. It just makes it more sustainable. And the elements had to be in lowercase when you used them, or the markup tag. So it was an improvement. XHTML is really for still presentation, not for data, and it was not ever meant to be a replacement for XML. Again, it was kind of a way to sort of take your HTML, if you will, to kind of the next level, but never designed as a replacement. You don't really hear the term XHTML used too much anymore. It was kind of something that I'd say from 2002 to maybe 2006, in that era, you would hear a lot of people talking about it, but not so much anymore. So why don't we use SGML anymore? What was wrong with that? Because basically it seems like that's what XML was, but back in the Stone Age. Well, one of the big problems was a lack of browser support, because all the development occurred before the World Wide Web was developed. You didn't really use browsers, at least how we know them. Pre World Wide Web, they had special ways of reading the messages that they sent back and forth, and to be quite honest, I don't know a lot about it. I didn't really use the internet too much before the World Wide Web. Too complicated to implement because there were too many options. SGML was really, again, a technologist technology, if you will. It was not really designed for sort of wide use and sort of used by lay people. Little support for style sheets, and no agreed upon standard that existed for presenting SGML data, so they did not have what you would call like a W3C standard for SGML. So the simplified subset of SGML was basically what became XML. It was small enough for web browsers. SGML web browsers had it was hard enough for them to implement XML, really hard for SGML to do it. And again, when you talk about browsers, you're always talking about standard W3C, following W3C rules. There was also no internationalized way of representing basically Unicode or ASCII text over the web with SGML, and that's one of the strong suits of XML, is that you can, and we'll talk a little bit more about this, but you could, say use a Cyrillic alphabet set, or Arabic, or Latin, Roman, English alphabet set. So that's something that XML can do quite well, and basically it does that because it implements Unicode, and it's too much for right now to talk about it, but we will talk about that later on. And XML is not really a language per se, it's more of a meta language. Again, this is the extensibility. It's designed to support the definition of an unlimited number of languages for specific industries or professions, and the idea is that you can write once and parse anywhere. I just mentioned Unicode. This is one of those things that I'll tell you about now, but as the course progresses on, you'll sort of get to know it kind of more from a hands-on perspective. But it's an international encoding standard for use with different languages and scripts, by which nearly every possible international character, letter, digit, or symbol is assigned a unique numeric value that applies across different platforms and programs. XML is written in Unicode. Again, Unicode is a way that if you are a German speaker, there are certain characters that they use when in the German language that we don't use in the English language, for example, like the S set or umlaut, those sorts of symbols or characters. XML allows you to use that, and again, SGML, that was something you could not use in there, in that technology. You perhaps heard me use this expression, but XML is self-describing. That's a buzzword that you still hear with XML today, that XML is self-describing. So you can use XML tags. We can make relationships between data explicit. We can prevent data loss due to inability to know what the data means. So again, self-describing, I can look at an XML document and know what all the data is marked up by the actual tags that were used. And it enabled domain-specific professions a way to mark up their information how they want. So again, you can create your own XML tags, and if you're say a professor or a researcher in the field of chemistry, you might have your own markup language. In fact, I know they do. Or math, or say you're in the sports profession, baseball, for example, you would have your own markup language that you would use to mark up scores and that sort of thing. So XML is great at being flexible and extensible for pretty much any profession or discipline that you can think of. It's interoperable, and XML allows for interoperability, and basically what that means is it can be used across many platforms. And when we're talking about platforms, we're talking about computer platforms. I can open up an XML document with many different operating systems. So pretty much what we use today is there's Windows, there's Mac, and then there's some version of Unix or Linux. But it can be used in many other ones. It's interoperable, and any operating system worth its worth its weight in salt will be able to implement XML. Same goes for programming languages. Every major programming language that you're bound to use out there, like say Java, PHP, Python, Perl, all those types of general purpose programming languages, they all provide support to use XML. XML is reliable, it's well documented, and it's an open standard. Again, there's the W3C again that makes XML a very a standard that any industry can get behind, because they know it's going to be supported by basically the whole internet community. Let's just talk about markup languages for a second. A markup language is a modern system for annotating a document in a way that is syntactically distinguishable from the text. There's hundreds of markup languages. Most developed in the past 20 years use XML. XML is the is sort of the lingua franca, if you will, of encoding information. It's a general purpose markup language used to create many domain markup languages. Again, that's that sort of meta markup language, if you want to think of it that way. And W3C Consortia writes the standards for XML and leaves the markup language development to the individuals or the authorities within their domain or profession or discipline, however you want to think about that. And now's the time you might think of a markup language that you might already know of if you're in the library track. There's one that's called MARC, M-A-R-C, or Machine Readable Cataloging Markup Language. It's not XML though. That's the one thing, because when I said before, there's a lot of industries out there that use markup languages. They might not necessarily use XML, although those people, those disciplines, if you will, are dying out. MARC, we will talk a little bit about in this class. I have a little bit of a bias because I'm a librarian slash archivist, so a lot of my references come from the field that I work in, but I try to make the class as general as possible, so any of you in different tracks or that go into sort of professions that don't have anything to do with libraries or archives, you'll still be able to obviously use these examples. But we have the library one as MARC, and the library community is trying to move out of MARC into MARC XML, but that's been a slow process. It is happening, and there is some momentum there, but it's been a long road because MARC XML has actually been around for at least 10 years, and there's still many libraries, including the one where I work at University of Albany Library. We are still using MARC as it was developed basically 4 or 5 decades ago. Well, there's another markup language, sports markup language, sports ML, math ML, green building XML, the text encoding initiative TEI. There's EAD, which is a really important markup standard for the archival community. These are all basically markup languages using XML. There could be, the list is in the hundreds of markup languages out there, so you can just do a Google search and look up any one you want. It's the backbone of the semantic web. You hear the semantic web talked about a lot, and it's sort of getting some more traction again with the web development community. It's integral to linked data. That's another term you'll hear used quite a bit. Integral to Web 2.0 and 3.0. Again, RSS feeds. Those are not really rocket science anymore, but they were a big deal when they came out. AJAX functionality like auto suggest when you do a keyword search in Google and you enter something like university, there's a way that Google, through its various technology, can start suggesting things, and it might actually suggest University at Albany, and part of that is an XML technology at play there that's allowing you to do that. It's a little more complicated than that, but XML is one of the key technologies that allow auto-suggest to come into play. Here's a little sort of picture how we might think of how XML works and kind of the ingredients or the paradigm that it uses. XML is like a mixture of Microsoft Word or a Word document. It does narrative really well, but it also can be like a database. Here we have an icon of Microsoft Access, which does databases. XML can be used like a database, and it also can be used to present information and data on the web. So it does all three of those things to one degree or another. It's kind of a marriage, if you will, of those three technologies. It separates content, structure, and presentation. So here you might have content over here, or the data, if you will, of like a narrative document, or it could just be a bunch of numbers or tallies from a report. You have structure, so it can show a hierarchy in data, which is very important. Showing structure and relationships, parent-child relationships, which we'll talk a lot about, or trees. That's something we'll talk quite a bit about in this course. And also you can do presentation, which ultimately at the end of the course we'll go from where we are now, which is learning how to just mark up data, all the way to the end of the course where we'll actually be presenting the data in a pleasing way over the web. So XML is like a database. It allows you to do things that you can do in a database. You can query it. If you've done any database work, there's SQL as a query language. There are other query languages out there, but SQL is a big one. You can sort it like you can in a database. You can sort data. You can query it, or rather in a database, you can query it and bring it back and sort it. You can update, add, and delete data. Just all the typical things you can do with a database. You can do this as well with XML. XML structures information. Like a database functionality, XML structures our information, but because it can structure data, it can be treated like a database, but it's more than that. It allows you to actually handle narrative information, and that's something that databases is never very good at. Often databases, how they run is they tend to like small pieces of data. Efficiency is always the sort of buzzword with databases, how fast you can make them run. And often there are character limits in a database table, if you will. And so, for example, trying to put a book like Moby Dick or The Tempest or a long novel in a database, it just never worked well with that, and XML is really suited for marking up narrative documents. So in a way, it can do both. It can do data and document. It's sort of a hybrid of the two. XML can represent small pieces of information or data in a highly structured manner. So you don't necessarily have to have a narrative document. You could just have say social security numbers or addresses, or like a basically like an HR type XML document where you just have little small bits of information represented, first, last names. XML can also allow you a way to reuse content. That's a word you hear a lot in XML, is data reuse. And again, it also represents the documents in a highly structured manner. So it's very popular in publishing, where XML is used a lot, and for example with the TEI or the text encoding initiatives, where they mark up text, like for example Shakespeare's plays, XML has been indispensable in allowing markup of those plays and novels and that sort of thing. You have a hierarchical data representation, so this is the proverbial tree or upside down tree. Here you have a family tree where you have a root. From there you might have a relationship to, say, a parent-child. You have a family, maybe a mother, father, and then children here. Again, family, children. You have some children there and a father. Let's go on to the next slide. That one doesn't really depict it quite as well. Here's something that's I made up this slide. I should actually just get rid of that slide. But we have a root, parents, children, and siblings. These are words or metaphors that we use to describe an XML document. So here we might have a root tag, if you will, or root element called the root node, and this root node is called library. The library might have children or a child, so it might have one book child or maybe many books children. So these two tags, if you will, their relationship to library are children or child again. They're also known as nodes. These are all nodes here, these blue circles. Library could have a child called books, but then the books could also have a child called title and author. And here we might look at this child-parent relationship as books is now the parent to the child title. Any node that's on what we call the same level, we might refer to those as siblings. So here we have books, and those are siblings of each other. XML is human readable. I mentioned this earlier. I can open up an XML file and inspect it with a human eyeball. It's human readable, and a computer can read it. So I can look at it and actually make sense of it with my own eyes and brain, just to distinguish it from a computer. But I can also write a program. Again, humans write programs that I can go through and read a document and actually sort it and do things to it, manipulate it, and do it because I know that it's human readable, that the tags have syntactic and semantic meaning to them. The one thing that's different about XML, we don't really get into it too much in this class. If any of you are in the library archives track and you get into digital preservation, this is things you might get into a little bit. But one of the distinguishing characteristics between, like, say, an XML document or XML file versus, say, a word processor file, a database file, or a spreadsheet file, the database word processor or spreadsheet files, those are all what we would call a binary file. So they're proprietary usually, and you can't just open that file up and look at it as plain text. You're always going to need the software to interpret that file. So I can't just open up a word processor file on my computer if I don't have Microsoft Word. Same with a database file. If I'm running say a MySQL database file, or a Oracle is a good one because that's a very expensive proprietary database system. I need Oracle to read that. Now you can migrate the file and do things like that, but to read it as an Oracle file, I need Oracle. Same with spreadsheet. If I'm reading an Excel spreadsheet file, I need Excel to read it. Again, you can migrate out of that, and there's ways around it, but basically those are binary files. And binary files are essentially bytecode, if you will, or zeros and ones, just to sort of simplify this conversation. And they're only meaningful to computers. A human could not read them without like a lot of serious help to figure out what it means. XML documents should be human legible and reasonably clear. Here we have some tags here. We have the meaning of an XML document should be more or less apparent from the tag. So here I have some data I've marked up here. This is terrier, so again, kind of just taking a stab at this. We can guess it's some kind of dog breed or dog. So here I've created two tags, or a tag, an element with an opening tag, closing tag, and that to me is very human readable, self-describing. I know what terrier is because I can look at the tags. It says dog breed. On the other hand, if we look at DB could mean almost anything. It could be database, dead boy, dog bone. We don't know, and we don't know if it's dog breed either. So we want to be careful of that. We'll talk a little bit more about this in the next slide. One of the terms, I can't remember if Goldberg uses it in the textbook, but one of the terms that's used widely in the XML community is the word verbose, or its opposite, which is terse. XML is not tersely written, or in other words, it's a very verbose language. Because XML documents are plain text, they don't take up much memory, so there's no point in using cryptic abbreviations. So here I have my first name marked up. I might as well just use something like first name for my element or my opening closing tags rather than FN. We'll keep coming back to this little point I want to make, but one of the reasons that XML took so long to be developed, and the World Wide Web and browsers and basically the whole sort of suite of technologies that allow us to use the World Wide Web, is that computing power was a valuable commodity, and it still is to a certain degree, but it really was back in the 60s and 70s, when you, in order to run a computer, you wanted to make the files, the programs, write them as efficiently as you can. So for example, this is a little bit of a sidebar, but if any of you are aware of the Y2K problem, that problem came about because programmers were trying to write languages as efficiently as possible on computers, for that matter. So when they made the date, there was basically only two spaces for month, day, and year. Now for month and day, that's fine. You can have January 1st, you have 0101, that's fine. But when you're going to do the year, and it's, say, for example, 1999, Well, that's fine. You can just put 99. So it's 01/01/99. Everyone knows that's January 1st, 1999. But when you decide to flip to, say, 2000 or 2001, you have a big problem, and that was the Y2K problem, because all of a sudden the computers were going to think it's January 1st, 1900 instead of 2000. So that basically, in a long story short, came about because programming and computing power was always a precious commodity. That has gone away because of Moore's law and just all the developments in computer technology. We have XML, so we can write our XML documents in a verbose sort of way, and the computers can handle it. They're not going to slow down. XML documents shall be easy to create. Basically, for this class, we could use just basically use Notepad and write all of our documents using this. Using this as our editor, so on and so forth. And I thought I'd just show you this for a second here. There are some faculty who teach an entire XML course or even programming using nothing but Notepad. My feeling on that is there's no need to suffer unduly when you're creating programs or XML documents. So instead what we use is Notepad. You've probably already seen it from the website. There are editors that are much nicer than Notepad++, and it's Notepad++, not Notetab. Notepad++. I'll have to fix that. There are ones that are proprietary that you can pay hundreds or maybe even thousands of dollars for. We're not going to use those. Notepad++ is free. It's great, and I think you'll find that it really helps you in the class, and it makes it so you can learn what you really need to learn and not have to fool around with sort of unnecessary problems that would arise from using Notetab. So here's a typical XML architecture. It's sort of a 1,000 feet up in the air. You basically have content, which is the XML document. You're going to have a style sheet, which we'll get to talk about it later on in the course, and then some kind of definition of the XML markup language that you're using, and what will enforce that markup language that it is indeed good and clean and using what you're supposed to use as a DDT. We'll also talk about XML schema as well in the class. Yep, too far here. And then the XML document, again, write once, use many times, or use anywhere. You may have one XML document. You could have actually possibly many, but in this case we have one. But you could have many style sheets, the ways that it's going to be presented to the web. So you might have an XSL style sheet that presents it to, say, one client base that uses your products, or say it's a library, you might have one way of representing it to children, maybe another one to, say, an adult reader community, maybe another to some special interest group. And then from that style sheet you get an HTML document. Again, this is just a little bit of an introduction to that. We'll get much more into this later on in the course. So XML is a sustainable standard. It's run by overseen by the W3C consortia. Libraries, archives, banks, almost every profession and discipline that uses information in a standardized sort of way is using XML today. They also use it as a preservation standard. It's very important if you want to have data integrity and have it preserved over time. We're talking about years, decades, or maybe even hundreds of years. XML is considered the standard of choice for that. It's lightweight. It's all just plain text. Standards driven, as I mentioned. It's well supported, and important, I would say one of the most important pieces of it is that it's open. So It's no company owns it. Like XML is not owned by, say, Microsoft or Adobe. It's an open standard that really belongs to the world. So here's just a picture. Perhaps if we watch the introduction to the course, you got to hear a little bit about my first computer. But here's an ad from a magazine for it. Again, you can see the price of it. $300 was actually a lot of money in the 1980s. And here's a link to a commercial to it. If you need some kind of diversion from your coursework, feel free to click on that, and you can watch that on your own time. It's very funny if you're a big William Shatner fan.